So the first thing it wants to know is what are the boiling points, and then it wants to know the freezing points. So I'm going to use this boiling point equation right here. And I'm going to make sure that I'm grabbing the KB. That's the most frustrating thing when you work everything correctly, but you grab the wrong constant. 512 degrees Celsius per molality. And in fact, that is the same equation for the next one also. And I want to point out that, again, the only reason that my molality is staying the same this whole time, the only reason, is because we're doing this in terms of moles. Someone has already done the moles. 1 mole of each of these substances would weigh it would have a different mass. So if this problem were being trickier and it were giving you, again, in the mass of them, the ethanol, it might be, like 40 grams would be 1 mole. The sodium, that would be like 58 grams would be 1 mole. And this one's going to be a whole lot more, well over 100 grams of it plus would be 1 mole. So again, the only reason that it happens to all be being the same is because we're trying to point out what happens with the temperature change and focus on that. So I'm going to fill this in. This is 1 times, and you can probably do this math in your head without doing a calculator. What's 1 divided by 2? You know this, it's 1/2. So 0.50 molality times 0.512 degrees Celsius per molarity. Now I'm going to do this one, and I'm going to do 1 times 0.50 molar. Oh, this is 2, right? I was jumping ahead of myself because I is 2 because it breaks into 2 of them, times 0.512 degrees Celsius per molarity. And then this one broke into 4. 0.50 molality times 0.512 degrees Celsius per molality. So I'm going to put this over here. And so I have 0.5 times 0.512. So this gives me 0.256 degrees Celsius. And then I'm going to that was an understood one, that's why I didn't put it in. But now this one will be times 2. 0.512. And I am throwing in an extra sig fig that I don't need to. I'll go back and fix it in just a second. And then again, same thing. On this calculator, I can also just type the equation instead of doing second entry. And this one gives me 1.024 degrees Celsius. I'll go back and make them 2 sig figs, or at least be aware that I'm doing 2 sig figs. Oops. 2 sig figs on this one would be that. All right, so the question's not asking what is the change of boiling point. It's asking what is the new boiling point. And since this is all water, then that means that we are doing 100 degrees plus this number. So that's going to tell me that this is 100.26 degrees Celsius. This one is going to be, because I took that to 2 sig figs, 100.51 degrees Celsius and 100.10 degrees Celsius. Now look, let's talk about adding things and make sure that we're completely clear. If it had told us that the boiling point of the water was 100.0, and a lot of times that is what we use as the standard for this. If you use 100.0, then what happens is that with the sig figs, when you're adding things with sig figs, you're going to add, and it's going to turn out like that. So technically, it would have been that. I'd have to round that up to 100.3. So you'll find in Gen Chem 1, we were really, really picky, everything about the sig figs. There's a lot of other math that we care a lot more about in Gen Chem 2. So a lot of times we'll just go ahead and make sure that you know the sig figs or how far we want something to be rounded. So just be aware of that. This problem may have said round to 2 sig figs, or it may have said round to 1 sig fig. I'll go ahead and just mention that this one would then round to 100.5 and this one would round to 100.1 if we were following that rule, because this is a shorter decimal position than these ones are, even if I took into consideration rounding that to 2 sig figs.